Welcome. This is the lecture for Chapter 16, Understanding Consumer Behavior. I think this chapter is not really named correctly. It should be called the Microeconomic Foundations of Macroeconomic Theory. Early macroeconomic theories, in particular Keynesian econ, were designed sort of from the top down. They didn't have what we today call microeconomic foundations, although we make many simplifications in macro and ignore most of the differences between individuals. We still hope that our macro theories are grounded in sensible micro. This is what we mean by macroeconomic theory having micro foundations. It's building macro from the bottom up rather than the top down in a sense. This chapter is structured to follow more or less the history of thought on the micro aspects of macro theory. First, we're going to look at the Keynesian consumption function, then at Irving Fisher's model of intertemporal choice, then the life cycle and permanent income theories of consumption. Then we'll see how combining the permanent income hypothesis with rational expectations gives us the random walk hypothesis. And last, we'll look at much more recent work, bringing insights from behavioral econ into macro. Behavioral economics is a branch of micro econ that studies the ways people are irrational, but predictably irrational. All right, the consumption function was introduced into macro by John Maynard Keynes in The General Theory of Employment, Interest, and Money in 1936. Recall that Keynes' model is based on a very simple consumption function. Consumption is just a function of disposable income, output minus taxes. And you can decompose this into a part that does not depend on income, that's C bar, and a part that does, which is the marginal propensity to consume times income. It's just intercept and slope. This simple Keynesian consumption function is not a bad starting point. It captures a number of plausible notions about people's behavior, that they will always want to consume something, that they will consume more as their income goes up, and that they will tend to spend some and save some of each additional dollar disposable income. We can summarize these nice realistic features as first, the marginal propensity to consume is strictly between 0 and 1. And second, the average propensity to consume is a decreasing function of income. To see that, pick a point on the consumption function. Like here, this represents a particular combination of consumption and income. Now draw a ray from the origin to that point. The slope of that ray equals the average propensity to consume at that point. At higher values of y, the average propensity to consume, or the slope of the ray from the origin, gets smaller. Keynes conjectured that these features were characteristics of actual consumption behavior. As income goes up, people tend to spend a smaller fraction of that income. Now, early work seemed to support the Keynesian consumption function. Surveys of households found that households with higher income both consumed more in absolute terms and also consumed less as a fraction of their income. They tended to save more of their income than did the poor. Also, aggregate data seem to confirm our intuition that both consumption and savings are low when income is low. As more data became available and more studies were conducted, the evidence started to show something else. First, the Keynesian consumption function implies that savings increases as income increases. So some economists started to worry that there would eventually not be enough good investments available, investment opportunities, to absorb all of those savings as the society became richer over time. It might lead to permanently inadequate demand and what's called secular stagnation, that is, a depression that doesn't end. It was feared in particular that this might happen after the end of World War II. But when World War II ended and we transitioned back to a peacetime economy, incomes did go up quite a bit, but the savings rate did not. That is, the average propensity to consume did not fall as incomes increased. There was a very famous study by Simon Kuznets who found that the average propensity to consume was stable over very long periods of time when incomes over those many decades had been going up. So it looked like there was a fundamental difference between short-run behavior in consumption and long-run consumption behavior. A difference between the short-run and long-run behavior that Keynesian econ couldn't explain. Now, it was really a problem, we know now, of comparing apples and oranges, or cross-sectional data versus time series data. If you take a snapshot of the economy at one point in time and look at the fraction of income poor people spend and the fraction of their income that rich people spend, you'll find that the marginal propensity to consume does fall as income rises. However, if you look at the if you look at the same data over time in time series form, you'll find that as our society gets richer, that is, all of our incomes are going up on average, we don't reduce the fraction of our income that we spend. Think of it this way. I'll just make up some numbers. Imagine a poor person who has an income of $100 and spends 90% of it, and a rich person with an income 10 times larger, $1,000, and the rich person spends 50% instead of 90. Well, that would fit with a Keynesian model of declining marginal propensity to consume. But now imagine that you wait a generation or two. The society became richer, and you now multiply everyone's income by a factor of 10. So now you have a relatively poor person with an income of $1,000 and a relatively rich person with an income now of $10,000. But they both spend the same fractions as before. The relatively poor person spends 90% and the relatively rich person spends 50%. So as we all get richer over time, the fraction that we spend appears not to change. Now the consumption function Keynes used does not include anything to deal with how people make decisions over time. But when people decide how much to consume and how much to save, they take into account both the present and the future. People face a trade-off in that the more consumption they engage in today, the less they can consume tomorrow. So they have to plan their consumption over time. In the 1930s, Irving Fisher developed an intertemporal model that illustrates how households make decisions about how much to consume and how much to save. If you think of consumption today as just one good and consumption tomorrow as just some other good, then you can analyze the decision of how to balance consumption of these two things, just like you did in principles when you were looking at how people divide their income between pizza and Pepsi. This is a very simple model of consumption over time that includes only two time periods, today and tomorrow. I should note that in this model, the day after tomorrow does not exist. So after the second period in this little universe, everything stops. So there's no point in consuming less than everything you have in period 2. You have income and consumption in both periods. You have savings, but only in period 1. Now, if you consume something today, you can't consume it tomorrow. Well, that's a budget constraint. So you do a little algebra, and you get this. This equation is the intertemporal budget constraint. It says that the present discounted lifetime value of consumption must equal the present discounted lifetime value of income. Consumption in period 1 plus consumption in period 2 divided by the interest rate. Income in period 1, income in period 2 divided by the interest rate. This is a graph of how a person can allocate consumption between today and tomorrow. This axis is period 1, consumption and income. This is period 2. If you spend today's income today and tomorrow's income tomorrow, then you would be, you would be here at point Y1, Y2. If you consume more today than your income today, you would be in this range. It would mean that you were borrowing. If you consume less today than your income today, then you're saving. Essentially, you'd be pushing income into the future or pulling it from the future to today by either saving or borrowing. Now, the slope of the intertemporal budget constraint, just like always, the slope of the budget line represents the relative prices of the two goods. In this case, that's the interest rate. If the interest rate is 10%, then you can trade 100 hamburgers today for 110 hamburgers tomorrow. Now, that was the budget constraint, which shows what you can do. But you also have indifference curves, preferences between consumption today and consumption tomorrow. These show what you want to do. And the slope is the rate at which you are willing to exchange consumption today for consumption tomorrow. It's the intertemporal marginal rate of substitution. And just like if you're dealing with two goods in the same time period, the consumer optimizes by choosing the combination of consumption today and consumption tomorrow that maximizes total utility, marked here at point O, the point where the budget constraint is tangent to the indifference curve. Now, since we're dealing with two time periods rather than two different goods, the optimum is where the marginal rate of intertemporal substitution between current and future income is exactly equal to the interest rate. So the rate at which you're willing to exchange present income for future income is the same as the rate at which you can exchange present and future income. Looking at intertemporal choice this way, you see that an increase in income today or tomorrow, represented by the budget line shifting out, will increase consumption in both time periods. Now, this assumes that consumption today and consumption tomorrow are both normal goods, which is a pretty safe assumption. The two-period choice model shows a weakness of the simple Keynesian consumption function. The Keynesian model assumes that consumption today is only dependent on income today. Fisher's two-period intertemporal choice model goes to the other extreme and assumes that consumption today only depends on lifetime income. When you actually receive that income makes no difference because you can shift income between time periods to any extent that you want at the current interest rate without any friction or additional costs. So Fisher's model says that consumption can rise in the present if expected future income rises, even if there's no actual change in current income. Under Keynes, that can't happen. Now, of course, we know that there are frictions and limits on how much you can shift income between time periods. You can essentially always push income farther into the future. You can always lend, but you can't always borrow. People have credit limits. We call this a liquidity constraint. This is the intertemporal budget constraint without any liquidity constraints. This person can borrow or lend without limit. Here's an example of an extreme case where the person cannot borrow at all. So the maximum possible consumption in time period 1 is income in time period 1. But this person does have the option of delaying consumption. So you can push current income into the future by lending. So you can potentially consume more in period 2 than your income in period 2. When you add an indifference curve to this kinked budget constraint, you come up with two cases. The first is where the liquidity constraint, the inability to borrow, is not binding. You can lend, and you want to lend. So your inability to borrow is irrelevant. And you do shift some of your current income into the future. Here's the other case, where the liquidity constraint is binding. This person would like to shift some future income forward in time to the present, but can't do it. If this person could borrow, they would be at point D on the red indifference curve. Actually, let me show something here. One moment. Here we go. I don't know if you can see this. There is a very faint dotted line that extends the linear budget line, which I'm highlighting very, very badly, all the way down to this axis. This person would, if this person did not have a liquidity constraint, point D is the point where these two are tangent. But since this person can't borrow, the best they can do is here at point E on the lower blue indifference curve. Now, Modigliani's life cycle hypothesis. This is, in a way, an application and extension of Fisher's model, but it has two important differences. First, it expands the model from just 2 time periods to many time periods, representing all the years of a person's life. Second, it assumes that people's preferences for how they allocate their income over time have certain common patterns. A stylized fact of economic data is that consumption is much smoother than income. This suggests that people may use saving to shift resources from times of high income to times of low income to maintain a more constant level of consumption. The life cycle hypothesis is based on the idea that people want to smooth their consumption over their lifetimes. In particular, therefore, They save during their working years to finance consumption during retirement. This model includes W, which is initial wealth. This could be zero, it could be receiving a gift at birth, an inheritance. Y, annual income, every year of the person's life until the person retires. This assumes you work from birth until you retire. It's just a simplification. It also assumes that your income is the same every year that you work. Just easy simplifying assumptions. R, the number of years you have ahead of you working until you reach retirement age. And T is the total number of years you'll live. To make things very, very simple, we will assume the interest rate is zero, and we'll assume that everyone prefers to have as little variation in consumption over time as possible. So, the lifetime budget constraint is total consumption over your life must equal total income over your life. Total consumption is consumption per year times T, the number of years you live. Total income is whatever you started with when you were born, W, plus the total number of years you'll work times your income per year while you're working. Now you want income to not vary over time. You want C to be constant. If you divide total lifetime income by the numbers of years you live, T, you will have exactly the same income every year of your life, whether you're working or in retirement. Now, one refinement here is the introduction of alpha and beta. This allows for the possibility that people view wealth and income differently in terms of their marginal propensity to consume. The reason why we include them is because there's very strong reason to believe that the marginal propensity to consume out of wealth is significantly smaller than the marginal propensity to consume out of income. As an example, think if you had a winning lottery ticket and you won, whatever, $1,000. You'd probably want to save a significant fraction of that because you know you're probably not going to win the lottery tomorrow. But if instead of winning the lottery, you got a raise and you knew that you would get that additional money every year reliably, then you'd probably be willing to spend a larger fraction of that raise every year, even if the total discounted value of the raise and the lottery winnings were the same. You'd spend a larger fraction of the raise than the lottery. Now we can look at a typical person's lifetime pattern of consumption. This shows that your wealth grows during your working years because you're saving towards retirement. Then wealth falls during retirement as you consume those savings. We call this here it is, dis-saving. The life cycle model is very stylized, but it makes important points in a very, very clean way. Now we can add things to the model to make it more realistic. But remember, a model being realistic is not the same as a model being useful. For example, we could add in positive interest rates. We could add more complicated consumption patterns. We could add uncertainty about future income, uncertainty about when you'll die, and so on. All these modifications would make the model more complicated, but the basic message would still be the same. We would still end up with some version of this picture. Now, Milton Friedman's permanent income hypothesis. The great Milton Friedman. His approach to consumption theory complemented the life cycle model. But unlike that model, the permanent income hypothesis focuses on the difference in consumption from two different types of income. permanent income, meaning income that you know is going to be relatively reliably there pretty much every year into the future. And on the other hand, transitory income. Transitory income is income from a random one-time event. This is income you can't predict in the future in advance, and you have no reason to believe that it will recur. Permanent income is like your salary. Transitory income like just getting a gift or finding a winning lottery ticket. His idea was that transitory income does not have as large an effect on consumption as permanent income does. If you get for example, $1,000 bonus at work because your company had a great year, you're likely to save most of it to try to keep your consumption smooth over time. But if you get a $1,000 raise, your permanent income is higher, and you're more likely to increase consumption by close to $1,000 a year. So Friedman argued that we can view consumption as approximately proportional to permanent income. Friedman's permanent income hypothesis really solves the consumption puzzle. Why we see different patterns in the short-term data and the long-term data on how the marginal propensity to consume varies with income. It's people with very high incomes also tend to have a larger fraction of their income as unpredictable transitory income. Less wealthy people tend to have a larger fraction of their income as permanent income. Imagine two people. The first person is making $20,000 a year, working at the grocery store. That person's income is going to be very predictable. It's essentially all permanent income. Now think of Bill Gates. If the stock market has a good year, his income could be $10 billion. But if the stock market has a bad year, his income could be zero or even negative. Now, I'm sure Bill Gates does have some permanent income, but the vast majority of his income is transitory because it's unpredictable from one year to the next. This is similar to the life cycle hypothesis if we view transitory income as changes in wealth and permanent income as changes in income. The marginal propensity to consume out of transitory income or wealth is low. The marginal propensity to consume out of permanent income is high. Which brings us to Robert Hall and the random walk hypothesis. He was the first economist to show how rational expectations can influence the pattern of consumption over time. He combined rational expectations with the permanent income hypothesis. If you assume that the permanent income hypothesis is correct, and add to that the assumption that consumers have rational expectations, then that leads to the conclusion that consumption should follow what's called a random walk, meaning that changes in consumption should be impossible to predict. The reason why it's impossible is because rational expectations means that people are already including every scrap of available information in their consumption plans. So the only thing that can change that planned out, perfectly smoothed consumption pattern is something that is by definition impossible for people to predict ahead of time. So people will only change their consumption if there's an unpredictable change in their income. Now, these kinds of changes happen all the time, but if individuals can't predict them, then neither can economists, because economists don't have access to any more information than consumers do. And we're assuming consumers use all available information in their consumption plans. This result is very important because many policies affect the economy by influencing consumption and savings, for example, a tax cut to stimulate the economy, only works if consumers respond to the tax cut by increasing spending. The random walk hypothesis says that consumption will only respond to the change if consumers had not anticipated the tax cut. Otherwise, it would be, in finance, they talk about information already being priced in to the price of a stock. In other words, it only works, the policy only has an effect if it's a surprise. An implication of this idea is that if we're trying to explain consumer behavior, we need to know not only if changes in income are temporary or permanent, but also if they are anticipated or unanticipated. If a consumer is told this year that he will receive a raise next year, the rational expectations view of consumption predicts that his consumption will increase this year, even though his income hasn't changed yet. And next year, by contrast, he will not alter his consumption at all, even though that's when the income change actually happens. So according to this theory, consumption responds to changes in the information about income. A simple Keynesian consumption function can't explain this type of behavior. The last topic for this chapter is much more recent work. By that I mean in the last few decades, which brings insights from behavioral economics into the study of macro. We know that people don't always behave the way our microeconomic models predict. Some economists have been looking to another discipline, in particular psychology, to try to understand how these apparent irrationalities work. I say apparent because we're working on theories, and this touches on my work a little bit, to try to figure out how these are actually not irrational behaviors. They're simply behaviors that economists don't understand yet. That's an aside. It turns out that quite a few of these deviations from our standard models of people as perfectly rational utility maximizers, deviations and departures from this model have quite a few consistent patterns. So in a way, people are irrational, but they are predictably irrational. Two of the leaders in this work were Daniel Kahneman and Amos Tversky. Dr. Kahneman won the Nobel Prize in economics for this work. It was lumped under a big title of prospect theory. But even though he won the Econ Nobel, Daniel Kahneman is not an economist. His background is psychology. As a side note, I want to point out that the reason why Amos Tversky did not share in the Nobel Prize is because he had sadly passed away at that point. And the Nobel Committee has an ironclad rule that they never give out the prize posthumously. So that's unfortunate, but every economist knows Dr. Tversky earned half of that prize, even though he couldn't be awarded it. One very prominent economist bringing insights from psychology into econ and the study of consumption is David Laibson. He observed that many consumers believe that they are poor decision makers. For example, in surveys, people very frequently report that they understand perfectly well that they are not saving enough for retirement, but they still don't save for retirement. Part of the reason could be that consumers' preferences, may be time inconsistent. in the sense that the passage of time itself may alter people's decisions. Let's look at an example from this is a very simple behavioral econ experiment. Now, if you had a choice between getting one candy today or waiting 24 hours and getting 2 candies tomorrow, which would you pick? Assuming you like candy. Now, seriously, pause the video for a moment and think seriously about how you would answer this question. What would you choose? When you're sure you know your answer, start the video again. Okay. Now, consider question 2. If you were offered one candy, if you today were offered one candy 100 days from now, or 2 candies 101 days from now, which would you choose? If you're like most people, in question 1, you'd rather have 1 candy today. But in question 2, you'd rather have 2 candies in 101 days. So if you ask someone today, would you rather have a candy in 100 days or 2 candies in 101 days, they are willing to wait 1 extra day for 1 extra candy. But if you were simply to wait and ask people the exact same question 100 days from now, question 1, then they typically would not be willing to wait the extra day. So sometimes the passage of time itself can change people's economic decisions. If you're interested in reading more about work in behavioral economics and how it interacts with public policy, this is not a bad place to start. It's a book called Nudge by Richard Thaler and Cass Sunstein. It was on the New York Times bestseller list for a very long time. Take a look at it. That's it for this lecture. I hope you enjoyed it, and I will see you next time.